emission tomography. So basically we can say it is a diagnostic tool of modern medicine, right? So let's see some of the uses of PET. Number one, PET is used for investigation, diagnostic, and treatment of, why we write number one? Okay. One, cancers. Number two, heart disease. Number three, gastrointestinal disorders, and brain function. Right. Just give me a second, please. Slight interruption. Now we're gonna write, hello, यार वो कैरोलाइन की क्लास आज फिर लेट है, कैन यू प्लीज़ आस्क? केमिस्ट्री के साथ कैरोलाइन की क्लास फिर लेट है, कैन यू प्लीज़ आस्क? हेलो, केमिस्ट्री की कैरोलाइन की क्लास इज़ लेट. Okay. Now, so difference between PET and CT scan or ultrasound, right? So we have done these two, we want to know. So the main difference is that PET looks at a patient from inside, whereas CT scan or ultrasound looks at patients from outside, because we have, transmitters and then receivers like that. Okay. The next thing we should know is in PET, a small amount of tracer, usually referred as radio tracer, is injected into a vein. It travels around the body and is absorbed by organs and tissues. Okay. Now, the radiations from the tracer is used to produce the image. In CT scan and ultrasound, we have to send external sources of energies, right? So it's not coming from inside, it's just crossing or penetrating the body. That's the main difference, right? Okay. Now, we can talk about that what are radio tracers. Number one, there are several different radio tracers used in PET. For example, glucose based molecule onto which a nucleide fluorine 18, right, is attached. This substance is called fluorodeoxyglucose. Okay. You don't need to remember the name, by the way, just for your information, that is. Now, the fluorine 18 nuclide decays by emitting a beta positive particle, which we call as positron. We learned this in AS as well. The advantage of using a glucose based tracer is that it is taken up at different rates by different tissues or organs. Now, the interesting thing here is that cancer cells are more metabolically active than surrounding cells. Hence, they absorb glucose at a higher rate and thus emit radiations at greater rate too. All right, you can write this down. Give me a second, please. I'm sorry. 1 minute, actually. All right. Okay. Now, the greater the amount of radiation, the brighter the spot on the diagnostic screen, right? Now, this allows doctors to identify, number one, diseases, number two, determine the progress and effectiveness of any treatment used for the disease. Is that clear, everyone? Let me know if you understand this. Rafi, Katika, Nadia, Sman. You guys are clear 100%?
Yeah.
Yes.
Okay, good. Now, now, usually we can also write the benefits of PET then. So number one, it is a diagnostic tool for detection of cancers, a diagnostic tool for investigation of heart diseases and brain injuries. Number three, investigates Alzheimer disease. Okay. And other forms of dementia. Number four, can pinpoint molecular activity within patient body rather than looking from outside. Can identify disease in early stages which can help in successful treatment. Others, basically, when there's too much damage, then you do X-ray or CT scan and makes things visible. So it's good in that sense. And can also give information about immediate and ongoing response to the treatment. Right, so these are 6. You can write them down, please. All right. Now, the next thing is what happens when a positron is released. All right. Now, PET scanners require a radioactive isotope that decays beta positive by beta positive emission. Now, 2. Since beta positive is an anti-particle, as you guys already know, to an electron, as it is released, less than a millimeter, it meets with an electron and the pair will annihilate. Okay, like for example, there is an electron and there is a positron. As soon as they meet, right, they annihilate, and when they annihilate, they release gamma rays, exactly 2 gamma rays opposite of each other, because they follow momentum laws, right? So this what you see right now, this is basically at 180 degree, both of them. So an electron and a positron gives 2 gamma at 180 degree of each other. That's something very, very important to remember. Now, annihilation causes them to release pure energy in form of gamma ray photons. Now, moving in opposite direction, as they always conserve, number 1, mass energy, and number 2, momentum, like that. Is that clear, everybody? Now, in this process, initial kinetic energy of positron is almost negligible because it instantly meets an electron, right? That's fine. Compared to their rest mass, energy. No. Hence, the gamma ray photons have a specific energy and a specific frequency that can be determined. That's fine. Okay. Now that solely by the mass energy of the positron and electron pair. And you know from the quantum physics that energy of photon is given by E equals to hf. And the momentum of photon is given by P equals to E over C. Okay, now let me just tell you what these are. So P is the momentum, right? As you guys know. E is the energy of photon. And C is the speed of light in vacuum. Just want to tell you that. So very important formula. Just remember that, please. Oh, my hand is tired by writing. That's not fair. Too much written work in this.
So what happens after the photon is released?
We'll let you know soon. Okay? Don't worry about it. Everything will be there.
Okay.
All right. Now. Oh. I'm resting my hand. You guys write. Then you guys can rest your hand. There will be. Usually, this chapter has very short questions. It's a very new chapter. But we don't know exactly. So we have to study everything. Well. All right. अच्छा. All right. Should I go forward then? Okay, so then the next thing we're gonna basically write about is the production of suitable radioisotopes. I just need to give you one space definition of radio tracers. But before we go there, I would like to write it here. The radio tracers. Okay. Interesting. मैंने आपको काफ़ी details that I gave you. चलो, we'll write it at that. No worries. Now, so what you're going to write is that this is basically a cyclotron. This is 2 half Ds, and on top of it there's an basically north and south. There's a magnetic field and then alternating supply. It just keeps on going. It makes a charged particle go round in circles and then keep on increasing its speed, so the momentum increases. And we have learned this formula before, which causes, as the speed increases, it causes the radius to increase, so it becomes a spiral, and we can hit the target nuclei, right, like that. So basically what we do is that magnetic field is perpendicular, like you can see right now, the process, to the D's. It moves charged particle in circular motion, and you know from this equation that we already know from magnetic field, the particle is constantly accelerated by changing the polarity of D's using AC current. So because F is EQ, you know this, and acceleration is EQ over M. Now, according to R equals to mv over vq, as speed increases, radius increases too. This causes this causes the particle to move in a outward spiral, like you see. Okay. All right. Okay. Now, when it reaches a required speed, it is targeted onto a target nuclei. For example, oxygen 18.8 is hit by this proton, which creates fluorine 18.9 plus 1 neutron and a gamma ray. There could be other traces as well, right? Now, if they say question, they say define radio tracer. So how do you write for 2 marks? Please write this, and then we're going to end this class, and we're going to do detection, reconstruction of image much later. Okay.
So in this example, oxygen is the target nuclei, right?
Yeah. Here we have oxygen, like this, and the proton is being accelerated in the cyclotron. Okay, like that.
And do we need to use Fleming's rule for this?
Yeah, you can use Fleming rule, of course.
Okay.
Yeah, and even if you use, it will be the same. So don't worry about that. It just, I made it randomly. Might not work here. So they won't ask you in this. You just need to know how and what equations are being used. Okay. Now,
Okay, sir.
so if they say define radio tracer as a question for 2 marks, so for the first mark you're gonna write it is a substance introduced into the body. This gives you 1 mark. So this is a standard definition. Do not forget it. I won't like it though. Also the examiner, absorbed by tissues that are being studied. So these are like 2 marks that will give you that you can get if this sort of question comes. All right, do remember that. Okay. Right. I just want to add one more little point, so you guys just try to write at this point, put a dot. Okay, put a dot here, and then write this is a positron interaction. All right, so this point is where it interacts, so it goes like this. Please write it down. Okay, I hope you're okay. Now you guys have any questions, please let me know up till now. So in one more class we're gonna finish this, and then yeah, things will be good.